Okay, moving on. This time we have how many different types of powers? We have three different types. We have our numbers, we have our, and two different variables, but you still have that exponent on the outside. First thing you want to do is make sure that every power in the parentheses has its own exponent. 3 to the power of 1, 2 to the power of 1. Now I am going to split this apart because we have three different types of powers. So I'm going to move my numbers out to the side first. Now, inside of the parentheses, we have 3 to the power of 1, and that is squared. The bottom part of my fraction, 2 to the power of 1 squared. Okay. Now you have one power with two exponents. Make sure you multiply. One power, two exponents, multiply. This becomes 3 to the power of 1 times 2. It's just an additional step. 2 to the power of 1 times 2. 1 times 2 is 2, so we get 3 squared. 1 times 2 is 2, 2 squared. Now you you may see it like this on the STAR test, but I really do feel like they're going to continue to simplify. Now 3 squared is not 3 times 2, it's 3 times 3, which gives us 9. 2 squared gives us 4, and we are done simplifying this section of the inside of my parentheses. Next part, we also have X's on the inside. Do you need to know? Yeah. So the next section is X. We have at the top, X to the power of 5. I am recording a video, Dontarian, for another class. Can you please give me a second and not talk about your throat hurting? X to the power of 5 is what's in the parentheses on the top side of my fraction. Don't forget that squared on the outside. We have X to the power of 3 on the bottom. It's also squared. Now this is very, very sloppy. Give me a second. Let me just straighten this out. X to the power of 5. Oh man. X to the power of 5 in the parentheses, outside exponent, squared. X to the power of 3, or x cubed, inside of the parentheses, squared on the outside. Don't forget to apply that squared to both of them. Now, when you have one power and two exponents, you multiply the exponents. One power, two exponents, multiply the exponents. So the top part of my fraction becomes x to the power of 5 times 2. The next part, x to the power of 3 times 2. 5 times 2 gives us 10. 3 times 2 gives us 6. Now, when you're dividing two powers with the same base, you subtract the exponents. X to the power of 10 minus 6. 10 minus 6 gives us 4. Now, since this is no longer a fraction, we know that this is going to end up being on the top side, or just write it out to the side. Okay, so the last section that we're going to break off are the y's. Let me switch color though. The y's do line up perfectly, so I can highlight it nice and neat. Here we go. So at the top of my fraction, the top power is y squared, but once again, you have that squared on the outside. Bottom part of my fraction, I have a y squared with an exponent of 2 on the outside. You have one base with two exponents. Make sure you multiply the exponents. One base, two exponents, multiply the exponent. So the top part of that fraction becomes y to the power of 2 times 2. Bottom part of the fraction, y to the power of 2 times 2. 2 times 2 gives us 4. 2 times 2 gives us 4. When we divide two powers and they have the same base, you subtract 4 minus 4. 4 minus 4 gives us 0. So y to the power of 0, it will end up canceling out. And the reason we say that it cancels out is because anything to the power of 0 will just give you the number 1. Let's see, let me show you. I can think of the most random number. You can't technically type variables into the calculator, but let's say a random number to the power of 0 gives you the answer 1. 4, 5, 8, 6, 3, doesn't matter. Anything to the power of 0 gives you the number 1. 2 to the power of 0 gives you 1. So if this part of it turns into the number 1, when I put all of this back together again, it would be 1 times 9 to the power 9 over 4 times x to the power of 4. But 1 times anything here is just itself. 1 times 9 over 4 will remain 9 over 4. To 1 times alpha y equals 9 over 4 is just 9 over 4. The fraction did not change. So it's the same as if this didn't exist. It's the same as if I would have canceled it out back here. So the answer is 9 over 4, x to the power of 4. All right, and I think we have 3 more problems. Let me see, should be back here, down here. Nope, not there. There it is. Nope. Here it is. 4 problems. Okay, now what we have in the parentheses are 2 different types of powers, or you have 2 powers with different bases. So I am going to split this one apart. Make sure that each one has its own exponent. And I'm going to move the s to the power of 1 over to the side. S to the power of 1, but we do have an exponent of 3 on the outside. Now, since this is at the top side of my fraction, remember to convert anything to a fraction, you put it over 1. And that's just going to help me remember what side of the fraction I need to write that back on when I put it back together. Now, when you have one base with 2 exponents, you multiply. And that gives me s to the power of 1 times 3. That over 1 still exists. And then 1 times 3 is 3, so s cubed. The other section would be the r's squared. But r squared, notice, is at the very bottom of my fraction, but this 3 here still applies to it. When you have nothing at the top, you want to put the 1 there. You can fill it in with the 1 or you can leave it blank, but just remember, this is the bottom of my fraction. We have one base with 2 exponents, so we multiply the exponents. And it's r to the power of 2 times 3, and 2 times 3 is going to be 6. Now that I'm ready to put it back together again, I'm going to start with my fraction bar. S cubed is at the top, r to the power of 6 at the bottom. Go into Thursday and it's part 1 or the full lesson. All right, so I'm going to assign this negative over to the f. Oops, right there. We do have an exponent on the outside. And I'm going to break the f off over here. We have to the power of 1, g to the power of 1. So in the parentheses, we have negative f to the power of 1 with a 5 exponent on the outside. That is the top side of the fraction. So I'm going to leave it over 1. 1 base, 2 exponents, you multiply the exponents. But remember, because my base has a negative, I'm going to leave it in parentheses. So negative f to the power of 1 times 5. Okay, now 1 times 5 is 5. And we said, or we wrote a rule in the first part of the video, that if your base is negative, then you have to look at the exponent. And if that exponent is an odd number, it's going to remain negative. So it's negative f. Okay. Let's go to the next part. My g's. But notice g is at the bottom of the fraction. So what's inside of the fraction is g to the power of 1. I mean, what's inside of the parentheses, g to the power of 1, but the 5 still applies to it. When you have one base with two exponents, you multiply. I'm going to leave it blank. That way you can see it both ways. And then that gives me g to the power of 1 times 5, still at the bottom. And 1 times 5 is 5. But now that I'm ready to put my my answer back together again, I look at that negative f, notice it's at the top, that g to the power of 5, and it's at the bottom. And that is my final answer. All right, last two examples. So we have s's and we have t's. We have a power of 3 on the outside. Each power already has its own exponent, so I'm just going to break the s's off to the side here. Now the top of my fraction has s to the power of 4, but that also has an exponent of 3. The bottom power is s cubed with another exponent of 3. Anytime you have one base with two exponents, make sure you multiply. One base, two exponents, multiply those exponents. So the top, we have s to the power of 4 times 3. Bottom, s to the power of 3 times 3. 4 times 3 is 12. And 3 times 3 is 9. When you're dividing two powers with the same base, you subtract 12 minus 9. You subtract the exponents. And 12 minus 9 will give us 3. The t, we're going to break the t's off. The top part of my fraction has t cubed with the power of 3 on the outside. Bottom part has t squared with the power of 3 on the outside again. All right, so one power or one base with two exponents, you multiply the exponents. Top part of my fraction becomes t to the power of 3 times 3. Bottom part, t to the power of 2 times 3. 3 times 3 gives us 9. 2 times 3 gives us 6. Sorry for all of the outside noise. Now we're dividing two powers, so you subtract the exponents. 9 minus 6. 9 minus 6 gives us 3. And once you're done simplifying everything, you put it all back together again. S cubed, t cubed, and that is my final answer. Okay. All right, last example. Don't forget, you have to circle your exponent on the outside. I'm gonna make it, I think I need to make this thicker though. Exponent on the outside right here. Make sure that every power has an exponent, or every base has an exponent. Now we're gonna split this into 3 sections because we have 3 different powers. We have a section of powers that has a number as a base. We have another section of powers that has m as your base, and another section of powers that has n as your base. So I'm going to start with my numbers. Okay, I have 2 to the power of 1 at the top of my fraction, but don't forget that 4 on the outside. I have 5 to the power of 1 at the bottom of my fraction with the 4 on the outside. Anytime you have one base with two exponents, you multiply the exponent. Multiply the exponent. So 2 to the power of 1 times 4 over 5 to the power of 1 times 4. 1 times 4 is 4, so that gives us 2 to the 4th. 1 times 4 is 4, 5 to the 4th. Now we can continue to simplify this further, and 2 to the power of 4 gives us 2 to the power of 4 will give us 16 at the top. 5 to the power of 4 gives us 625. Now remember, with every fraction, you want to simplify it if possible. So that will give me 16 at the top, 625 at the bottom, and that does not simplify. So now we got to continue. Next section, we have our m cubes, okay? So top part of my fraction has m cubed to the power of 4. Bottom part of the fraction has m cubed also to the power of 4. When you have one base with two powers, multiply the exponents. One base, two powers, multiply the exponent. So giving us m to the power of 3 times 4 over m to the power of 3 times 4. And 3 times 4 gives us 12. When you're dividing two bases, when you're dividing two powers with the same base, you subtract the exponents, and 12 minus 12 gives us 0. Now remember, anything to the power of 0 gives us 1, so it's like you're canceling out. But you still need to know that it gives you the number 1 for the future, okay? Last section, we have our n's. So inside of the parentheses, n to the power of 5 to the power of 4. At the bottom, n squared to the power of 4. So anytime you have a power with a base and 2 exponents, 1 base, 2 exponents, you multiply. So that gives us n to the power of 5 times 4 over n to the power of 2 times 4. 5 times 4 gives us 20, and 2 times 4 gives us 8. You're dividing you're dividing two powers with the same base, so you subtract 20 minus 8. You subtract the exponents, and 20 minus 8 will give you your 12. After you're done, you put it back together again. But remember, 1 times anything is itself. That's why technically you say that it cancels out. So 16 over 625. And n to the power of 12 is at the top of the fraction. There's nothing under it. It's not under anything. So you just want to write it at the top, or you could also write it to the side. Up to you.